So in this video, we are going to discuss the paper 6 from October-November 2023, paper 6-1, which is 36 lah, right? Okay, so let's start with question number 1. We are given a random variable x, and basically it is normally distributed. So you see the distribution here, right? It is normally distributed. So they want us to find the probability that the mean of a random sample. Please highlight the keyword mean of a random sample. Basically, this means that x bar, right? Mean of a random sample, sample mean, right? So to calculate the probability about the sample mean, so this already tell you that it is a sampling distribution. Okay, so for sampling distribution, you need to recall a little bit, yeah. When we are writing anything with x, it is population. All right, so x is population. If I'm having x is normally distributed with mean and also the variance like that, then when we are going to get the sample mean from this population, generally the mean of the sample mean is the same. Okay, the mean of the sample mean is the same as the population mean. And for the sample mean, right, the variance of the sample mean, basically we have to take the variance of the population then divided by sample size. So basically it will be sigma square, which is the variance of the population, then divided by the sample size. N will be the sample size. All right, so this is some very basic idea on sampling distribution. Okay, and then for this question, because of the population is originally normally distributed, so automatically the sample mean from this population will be also normally distributed. All right, so this is something basic that we need to know before you can set up the question correctly. Okay, so first of all, I know that my population is normally distributed with this mean, and also the variance is 400. Therefore, if I want to get the sampling distribution, okay, for the sample mean, what will it be? So again, the first number here will be still the mean. Okay, so the mean will be the same as the population mean. And after that, for the variance, right, you have to take the population variance, which is 400, and divide it by sample size. So what is the sample size in this question? 36 will be the sample size. And we make this as n, right? So divided by 36. Okay, then you try to simplify them. I think you should get a fraction also, which is 100/9. So I just keep it as a fraction form so that later when we do any calculation, right, we'll use the most accurate value here, right? Okay, so go back to the question. They're asking us to find the probability. So I write a P, probability, mean of the random sample. That means sample mean. So I'm having x bar less than 405. So smaller than 405. Okay, so please take note that we already know just now, right? The sample mean distribution here is also normally distributed because the population originally is normal. So my sample mean is also normally distributed. Therefore, to calculate the probability for sample mean, just like what you do in normal distribution before, you have to change it or standardize it become Z first. Alright, so you have to take the value of the sample mean minus the population mean or minus the mean divided by the standard deviation of the sample. So the of the sampling distribution. So the standard deviation will be square root of 100/9. Okay, so we can use calculator to help us a little bit. By right, you should have a very nice number, which is negative 1.5. Okay, then how to get the area for negative 1.5? Z smaller than negative 1.5. Okay, so just again, if let's say you are the one who don't really understand how to get the probability, then you can have a look for this part. So you always assume that the standard Z is 0 in the center. So negative 1.5 should be somewhere here. Okay, and the symbol smaller than means that we are interested to find this particular value, this particular probability or the area. All right, but too bad, in our normal distribution table, right, our Z value, there's no negative value in our table. So you can have a look here. This is the Z value, and all the Z value are positive, right? Okay, so there's no negative value. Therefore, what can we do is that we have to find a way, okay, to change it become a positive Z. So since the normal distribution graph, right, they are symmetry in the center. Therefore, the area that you want to find out here basically is equals to the area on the positive 1.5 greater than. So these two areas basically should be the same. Okay, all right. So now that means I'm interested to find out z greater than 1.5. To get z greater than 1.5, right, the small area here, again, you go back to the table, you can see that our table giving the value, okay, the probability that's smaller than. So you see this part, right, smaller than. So that means, let's say this is 1.5, okay, the answer in the table here, they give us the area of probability that's less than 1.5. Okay, so if you look at 1.5 here, the value is 0.9332, right? Okay, so this is 0.9332. Then the 9332 basically means this one. But we are interested to find out this area. That means what? That means you have to take the whole area, which is 1, minus the answer that you get in the normal table. Then only you can get the small area that we want. Alright, so in our step, we have to show out this one. So to get z greater than 1.5, it is equals to 1 minus 0.9332. Okay, then again, try to press calculator and help us a little bit. So by right, you should have 0.668 as the final answer. So this is how we solve question number 1. Question number 2. We are having 300 adults selected in a survey, right? To be involved in a survey. Then 134 said that they exercise regularly. Okay, then this information was used to calculate an alpha percent confidence interval. Okay, for proportion of adults in this country or this place who exercise regularly. So mainly this question is about the confidence interval of proportion, right? So the upper bound of the confidence interval was found to be 0.487. Okay, so this is the information that they give us to start with the question. Then want us to find out the alpha correct to the nearest integer. Okay, so first of all, we need to know for any confidence interval, right? Basically, the confidence level alpha has the meaning of the percentage in the center, okay, or that means that form the width of the confidence interval. So which means I have two value here. So the center value here will be the alpha percent. Okay, or maybe you can put it as alpha divided by 100 if you want to have a probability. Okay, and then due to the characteristic of the normal distribution graph, right? Okay, they are symmetry to each other now. So that means the area on this side and also the area on this side, okay, should have the same area as well. So how to get the area for these two, or the probability of these two? So basically it should be 100 minus alpha divided by 2. Because after you take 100 minus the center part, so the remaining area you have to divide by 2. So this small area here is 100 minus alpha divided by 2, then percent. Okay, then same thing for this side also, 100 minus alpha divided by 2, and then percent. Okay, all right, so now, what is these two value here? Basically, these are the values that we have. Okay, and we actually need to find out the value of z first before we can use it to find back the alpha, the alpha percent. All right, so first I have to find out the value of z, okay, from the confidence interval. And after that, only I can use the z to find out alpha. So how can we start? So basically, we can start from this value here. They are telling us that the upper bound of the confidence interval was found to be 0.487. So what is the formula for the upper limit of the confidence interval in this case? So again, I want to emphasize the confidence interval for this is confidence interval for proportion, not for the mean. Okay, it is for proportion. Therefore, the formula is the upper limit. So maybe I should put like this, the upper limit of the confidence interval, okay, will be equals to P plus Z square root PQ over N. So that's the value for the upper limit of a confidence interval for proportion, right? For mean one, then it will have something like sigma over square root n. But this is for proportion, therefore this is how the formula look like. So upper limit is already given in the question, which is 0.4487. Right, so how to find the value for P? So the P, you can get the proportion from the survey or the information given here. So total you're having 300 chosen adults in the survey, and then 134 fulfill the requirement. So to get the proportion, it should be 134 divided by 300. This is your P, right? Then plus Z. Z we actually don't know and we want to find it out for now. Okay, then square root, I just put it as square root. Okay, what is the P again? So P is 134 over 300. What's the Q? So Q is the opposite of P. That means you take 300 divided by 134. So you should have 166 over 300 divided by N. So how to divide it by N? So N, what's the number that we have, the sample size that we have? So the survey involved the 300 adults. So the N should be 300. Okay, all right. So after this step, please make sure that you try to press calculator carefully because it looks like there are a lot of fraction here, right? So there are a lot of steps for you to press the calculator. So try to move everything over, and we are going to get the value of Z. So take some time, try to make sure that you didn't do any careless mistake. By right, you should get Z equals to 1.405. Okay, so we successfully found the value of Z by having this upper limit. So it should be 1.405. And which means also this one, this value of Z is 1.405 for our question here. Okay, so now I'm interested to find out this area. Okay, I'm interested to find this area so that I can compare this area with the percent here. Some students, they might want to find out the area smaller than also can. So some students might want to find the smaller than area. Okay, but if you want to find out the smaller area, right, the smaller than 1.405 area, later if you want to find the alpha, then might be your step might be slightly longer. Okay, so for me, I use a more straightforward one where I use this one, Z greater than 1.405. Okay, so I'm interested to find out the probability of Z greater than 1.405. Again, to find out Z greater than 1.405, I have to take 1 minus the value that I get from my table. So 1.405, where's your 1.4? 1.40 is this one, right? Okay, so that means you should look for this value. 1.40 and then 5. So 5, you can go to the back. So what's the 5 here? So the 5 here is a 7. So that means you have to take 9192 plus 7 as at the last digit. So you should have 9199. Okay, so the value that I get from the normal distribution table here, okay, it should be 0.9199. Okay, then what do I get? After I minus it, I will have 0.0801. Alright, then now, after I successfully find out the value of the probability Z greater than 1.405, I want to compare this probability with the percentage that I have here and that we tried to draw just now, right? So this area is 100 minus alpha divided by 2. Therefore, now I want to compare 100 minus alpha divided by 2. Because the alpha is in percentage, so that means when you want to compare it with the probability here, you have to convert this probability into percentage as well. So it should be 8.01. Okay, then from here, when you try to move all the number to the other side, you'll get 83.98. So your alpha is actually 83.98%. Okay, so the confidence level for this confidence interval basically is 83.98%. But if you try to read the question carefully, again, they're asking you to find the value of alpha correct to nearest integer. So they're interested for the nearest integer. So we go back to our answer again. Alpha is 83.98, so you can round it off to 84, which is the nearest integer. Okay, so this is how we decide the alpha basically. Alright, so every time when they want to decide the alpha percent, the alpha percent in the confidence interval, the very first thing is we have to find out the value of z for this particular confidence interval first. That after that only we can decide or we can calculate and get the value for the alpha. Alright, so this is how we solve question number. Okay, so question number 3. There's a website owner finds that on average, his website received 0.3 hits per minute. So highlight this phrase. Okay, when you see the average number is given in the given interval per minute, okay, or maybe per hour or whatsoever. So this question basically tells you that it's a Poisson distribution. But for this question also, they already tell you the keyword here, okay, follows the Poisson distribution. So assume that the owner is correct. Find the probability that there will be at least 4 hits during a 10-minute period. So to calculate the probability in Poisson distribution, you have to change the mean according to the interval that we have. So they are given us the average for 1 minute, but we are having a 10-minute period. Therefore, before we start calculating the probability, we have to change it become the lambda or maybe the mean with 10 minutes first. So 0.3 is for 1 minute. So if I'm having a 10-minute period, so I have to multiply it with 10. Therefore, the lambda for 10-minute period is a 3, or the mean for 10-minute period is 3. Then only we can start to calculate the probability. Okay, so find the probability that there will be at least 4 hits. So the number of hits will be more than or equals to 4. Okay, so for Poisson distribution, there's no limit for the value of x. So x can start from 0, then 1, 2, 3, 4, 5, 6 until infinity. So when there's no limit for the value of x, it is impossible for us to get the answer by using this way. So what we're going to do is we have to take 1 minus x smaller than 4. Okay, right, so what's the formula for this one, x smaller than 4? Okay, so just a little bit of recall. Of course, if you already forget the formula for Poisson distribution, I think you can try to find out from our table, right? From our formula booklet. Poisson, yeah, this one. All right, so this is a Poisson distribution. Okay, where if you're having x equals to 1, r is 1, then this is a general formula, e negative lambda, lambda power 1 divided by 1 factorial, and so on. Okay, so you can get the formula from this part. All right, and then usually for me, right, I will ask my students to remember the shortcut for, not to say shortcut, but another formula that we can apply easier, where you want to find x smaller than a number r. Okay, so the general formula is e negative lambda. First term is 1, always a 1. Second term is always the lambda. Then plus lambda square over 2 factorial, lambda 3 over 3 factorial, until lambda power r divided by, maybe I should put an equal sign here, until power r divided by r factorial. Where this is actually the probability of x equals to 0. Multiply e negative lambda inside, so it will be x equals to 0. Then this one with the probability for x equals to 1, x equals to 2, x equals to 3, and so on until x equals to r. Okay, so this can solve a little bit of our time when you want to press the calculator. Okay, right, so I will apply it here. Okay, so x smaller than 4. So x smaller than 4 means that I'm having e negative lambda. I want to include the probability for x equals to 0. First term is a 1. X equals to 1, which is a 3. Okay, x equals to 2 means 3 square divided by 2 factorial. Then x equals to 3 is 3 square divided by 3 factorial. So smaller than 4 means doesn't include the 4. Therefore, I will stop here at x equals to 3. All right. Yeah. So by just pressing calculator, I try to use the calculator to help you a little bit. So the answer that you get for this part should be, okay, it is a long value. Of course, we have to change it become 3 significant figure as the final answer. A, number 1. Okay, so let's continue to part number 2. Okay, use a suitable approximation distribution. Highlight the keyword approximating. Find the probability that there will be fewer than 40 hits during a 3-hour period. Okay, so now they already tell us a very obvious keyword approximate distribution. That means you have to change Poisson become some other thing else, right? So before we can change Poisson become some other thing else, right? I need to know what is the lambda or the mean for 3 hours. Okay, so again, 1 minute is 0.3 hit. So 3 hours means 180 minutes, right? So you have to multiply with 180. Therefore, you get 54. When your lambda, this is your lambda or the mean, when your lambda is more than 15, basically you can change Poisson distribution, become normal. So that's why they're asking us to approximate, use the approximate distribution here, right? Okay, so we are changing Poisson, become normal distribution. And for the first value here, it should be the mean, right? So the mean is actually the lambda in Poisson, which is 54. And how about the variance? So for Poisson distribution, it has a very special characteristic where the mean and also the variance are having the same value. So if your mean is 54, therefore the variance should be 54 as well. So you put it as 54 here. All right, then now we start the calculation for the probability. So they're asking us for x smaller than 40. Fewer than 40 does not include the equal sign. Okay, so for your information, right, this is the value for x in Poisson, where Poisson distribution is discrete random variable. Okay, then the normal distribution is continuous random variable. Therefore, when you are trying to change a discrete random variable to continuous random variable, you have to apply continuity correction. So the continuity correction is either plus 0.5 or either minus 0.5. So smaller than 40 will give us smaller than 0.5 lah, minus 0.5 lah. So it should be 39.5. All right, so if you need a way to remember this process, right, whether is it plus 0.5 or minus 0.5, please go and search for from my playlist that includes the lecture notes video, okay, about this topic, chapter 1, right? So you can have a look for the continuity correction in details, right? Okay, then now, after you apply for continuity correction, so please change it become Z, okay, because it is normally distributed, right? So you have to change it become Z, where again, you have to take the value of X minus the mean divided by standard deviation. Okay, so standard deviation means you have to take square root 54 lah. Alright, then what's the value of Z that we get? You should get negative 1.973. So please kindly take your value of Z up to 3 decimal places when you want to find out the value from the table later. Okay, so this value must be up to 3 decimal places, yeah, so that we can get the most accurate answer from the table. Alright, so again, we are looking for Z smaller than negative 1.973. This is 0. So negative 1.973 is here. Then they are saying that smaller than 1.973. So this is the area that I want to find. But again, like what I mentioned just now earlier in question number 1, right? Our table didn't give us the probability for the Z, which is negative value. So I have to reflect it to positive value here, 1.973. And this is the area that we are interested to find. But in the table itself, they only give us the area on the left hand side, this one, the white color one. So to get the correct final answer, I have to take 1 minus, then we are going to look for Z smaller than 1.973. So again, where's 1.973? So you look for 1.9, 1.97. So that means it's this one, 1.97, then 3. So where's the 3 here? This is the 3. So I'm going to take the value for this, which means that you have to take 9756 plus a 2 at the last digit of the 9756. So by right, you have 9758. Okay, so go back to our steps here. So you have to take 1 minus 0.9758. Then I'm having 0.0242. So this is already the answer in 3 significant figure. Right? Yeah. Then let's continue further. Then for part number B, they are saying that there's a friend agreed that the website receives on average 0.3 hits per minute. However, she noticed that the number of hits during the daytime is usually twice the number of hits during the night time. So now they are asking why this fact contradicts the owner's belief that the number of hits per minute follow a Poisson distribution. So if if you have a look here, when they suspect that the mean should be different, the number of hits on daytime is higher, twice the number of the hits during the nighttime, right? So basically, this doesn't fulfill the Poisson distribution anymore. If you're having two different two different mean, okay, for the day that you want to consider, right? So they ask us to explain why lah. So basically it is because of number of mean. The mean is not constant, so you can write the number of hits, or the mean also can, for 1 minute is not constant. Okay, all right, so let's proceed to part 2. Now they want us to specify separate Poisson distribution that might suitable model for the number of hits during the daytime and also during the nighttime. So now, since we said that it might not be fulfill the characteristic or the condition for the Poisson distribution, right? So now they want to separate it into 2 sessions. So one session is daytime, one session is nighttime, and they want us to find out the mean for daytime and also the mean for the nighttime. So how can we find out the mean for daytime and also the mean for the nighttime? So this calculation, basically you should, maybe we are using some very common sense, alright, in maths, and also the ratio, okay, to get the answer. So we are talking about number of hits per minute daytime. So for daytime, one is twice the number of hits during the night time, right? So I write as 2p. Then the number of hits per minute for night time, I will define it as p, okay? Right? So by right, when I take 2p plus p, right, it should be equals to 0.3 plus 0.3. Why? Because 2p means per minute. So per minute, originally it is 0.3. We assume that it is 0.3. Then for the night time, this is also per minute, right? Okay, so for the night time per minute, averagely, I also have 0.3 hits that we assumed just now. So also plus 0.3. So when you add them together, you are having the value of p, which is equals to 0.2. So that means now you can separate your Poisson distribution into 2 different parts. For the daytime one, you can still assume that it is Poisson distributed. And then what's the mean? The mean will be 2p. So 2p means 0.4. Okay, then how about the night time? So for the night time, also Poisson distributed, and the lambda is actually the 0.2. So the 0.4 here and 0.2 here is the lambda for 1 minute. Because when you do any calculation just now, we are using minute as a unit. Okay, as an interval. Alright, so this is 0.4 per minute, and also this is 0.2 per minute. How we solve this question? Okay, so now we are at question number 4. we are having the mass in kilogram for chemical A and B produced per day by a factory. So they put it as Y and also X. So X is the A. Okay, they are both normally distributed. Okay, then if you want to calculate the income, right, the income generated by the chemical is 0.5 per kilogram A and also 3.25 per kilogram for B. Okay, so first they want us to find the mean and also the variance of the daily income generated by chemical A. So maybe I put it as income, income by A, chemical A. So to calculate the income, right, just now we know it is 2.5 per kilogram in A, right? So it should be 2.5 multiplied with the X. Okay, so you have to know what is the mass of the chemical A, then multiply with 2.5 because 1 kilogram should be 2.5. Okay, then how can I calculate the mean for the income from A? So to calculate the mean from the income from A, it should be 2.5 multiplied with e power x, ex. 2.5 multiplied with ex, the mean of x. So what should it be? It should be 2.5 multiplied with 10.3 because from the normal distribution here, okay, the detail here, you can see that 10.3 is the mean. So you put 10.3 as mean, then calculate them, you should get 25.75 as the mean of the income A. Okay, then after that, the question wants us to calculate the daily income, the variance for the daily income. Okay, so now I want to calculate the variance. So to get the variance, it is actually variance 2.5x. Okay, then now when you want to take out the 2.5 from the variance, right, you have to square it because this is multiplication. 2.5 multiplied with x. Therefore, when you want to calculate the variance, I have to take out the 2.5 and at the same time you have to square it. Then you take 2.5 square, multiply with the variance of the x. So by right, you should have 2.5 square multiply with variance. You can get it from the info here just now, 5.76. Okay, so if you didn't do any careless mistake, by right, the variance should be 36. Yeah, then let's continue to part number B. So for part number B, now they want us to find the probability that on a randomly chosen day, the income generated by chemical A is greater than the income generated by the chemical B. So you can see that there are two different variable that we are interested in. We want to consider income generated by chemical A and also income generated by the chemical B. Just now, we already calculate the mean and also variance for the A. So before we can continue to calculate the final answer for the probability, definitely we need to find out the mean for the B first. Okay, so maybe we can write out the definition for the income from B. Income from B means that you have to take 3.25, which is the price per kilogram, multiply the Y, the weight or the mass of the chemical B. Okay, then if I want to calculate the mean for income of chemical B, it should be 3.25 multiplied with the mean of Y. So again, what's the mean of Y? You can get it from the question just now, 11.4. Okay, then we should have 37.05. Then you can calculate also the variance. When you want to take out 3.25 from the variance, you have to square it. So multiply with variance of Y. So you're having 3.25 square. Look for the variance of Y here. It should be 9.61. Okay, so if I try to press calculator, I'll get a quite a long value here. Okay, so because this is not my final answer yet, right? So usually for me, I will just keep it as long as possible, like what the calculator showed me. Alright, I will need to use this full value later for the calculation of probability. Alright, okay. Then let's have a look for the question here. So they are saying that find the probability that the income generated by chemical A, means IA, no? Greater than, so more than, income generated by chemical B, so IB. Okay, so please take note that when you want to do any calculation, right, for probability, if you are having both sides with variable, basically you cannot continue with the calculation for the probability. You cannot have both sides with variable. Therefore, to calculate the probability, you have to move one of the variable, you have to group all the variable to one side. So that means it should be IA minus IB greater than 0. Okay, so to do the calculation for probability, to calculate the probability, you have to find out the mean and also the variance for IA minus IB first. Because we know that everything here is normally distributed, right? Therefore, IA minus IB should be also normally distributed. Okay? Alright, so now, before we start to calculate the probability part, we try to calculate the mean and also the variance for IA minus IB. So mean of IA minus mean of IB, you directly take mean just now, 25.75 minus the IB, 37.05. So you should have 25.75 minus 37.05. So you should get a negative value, so negative 11.3. Then how about the variance? Okay, so to calculate the variance, you take the variance for the A, which is 36. In the variance, there's no negative, so we have to change it become plus always. Alright, then what's the variance for B? So it should be this one, 101.505625. Okay, then again, it is 137.505625. Again, this is not my final answer yet, therefore I keep my value as long as possible. Okay, so like what I told you just now, right? Since we know that all the A, B, X, Y are normally distributed, so IA minus IB is also normally distributed. So you're having negative 11.3, and also the variance is this long value here. Okay, then after I get all the values that I want, so I can start the calculation for the probability. So they want us to find IA minus, by right it should be IA greater than IB, like what I tell you just now, right? But we cannot find out the probability when having both sides with variable. So I have to group all the variable to one side, become IA minus IB greater than 0. Okay, so since we know that they are normally distributed, therefore you have to change it become Z. So I'm having 0, standardize it. So minus the mean. What's the mean for IA minus IB? This one. Minus negative 11.3 divided by square root of the variance, which is 137.505625. Okay, then again, after you press the calculator, get the value of Z up to 3 decimal places. So it should be Z greater than 0.964. So to calculate the area, you need to take 1 minus. Then we look for 0.964. So where's 0.964 here? 0.96 is this one. Then 4 is 10. So that means you take 8315 plus 10 as the last two digits. So you're having 8325. Okay. Then they are looking for greater than, so I have to take 1 minus 0.8325, the value that we get from the table just now. Then by right, you are having 0.1675. Okay, or usually I will keep it to 3 significant figure, which is 0.168. Okay, yeah, so this is how we solve this question number 4. So question number 5. In the past, yeah, the number of the inquiry for per minute. Okay, so highlight the keyword per minute. this is the interval given, right? At a customer service desk site has been modeled by a random variable with distribution Poisson 0.31. So the lambda or the mean for 1 minute is 0.31. Following a change in the position of the desk, it is expected that the mean number enquiry per minute will increase. So here the keyword will increase. So this will be a keyword for us, or maybe a hint for us to set up our null or alternative hypothesis later, if let's say they want us to carry out the test, right? So in order to test whether this is the case, the total number enquiry during a randomly chosen 5-minute period is noted. So we are interested for the 5-minute period. Okay, when you want to carry out the test, we are interested for the 5-minute period instead of the 1 minute. So you should assume that a Poisson model still appropriate. Okay, given that the total number of enquiry is 5, so this is our observed value. And basically, we are going to use this observed value to calculate the p-value later. Alright, then they want us to carry out the test at the 2.5 significance level. So again, 2.5% here will be our alpha, which is the significance level. Okay, so first of all, to set up the test, right? So it is quite obvious that we know this is a Poisson distribution test. The test on Poisson distribution mean. Okay, so they only give us the mean for 1 minute. Therefore, when you want to carry out the test, right, you can change it become the mean for 5 minutes. So you can try to calculate the lambda first. So for 1 minute is 0.31, right? So this is for 1 minute. So if we are interested for the 5-minute period, so I have to multiply with 5. And therefore, you're having 1.55. Okay, so after you find out the mean already, or the lambda, so you can start to carry out the test. Okay, so just a very quick recall about all the steps that we need to include in our hypothesis test, yeah? So of course, for the first step, you have to set up the null and also alternative hypothesis. So for the second step, you need to calculate the p-value by yourself. So how to calculate the p-value? Using the observed value, and usually it will be given in the question. After you get the p-value or the probability, then the next step is you compare it with alpha, which is your significance level, and after that you make a decision with conclusion. Okay, so basically these are the general steps that you need to show in carrying out the hypothesis test. So let us start. So first step, we are going to start with null and also the alternative hypothesis. In our syllabus, okay, so we are always let the null hypothesis put it equals to, okay, the sign with equal sign, always in the null hypothesis. So it is equals to 1.55 for 5 minutes period. Okay, so if you have a look for the marking scheme, right, it is not wrong that you write 0.31 for 1 minute as your null hypothesis. It is still correct. Okay, but for me, I prefer maybe to make it become the 5-minute period so that I know that, oh, my lambda actually is 1.55. Okay, then after that, how should we set up the alternative hypothesis? So you have to look at the statement inside, okay, in the question here, which is the keyword, okay, to help us to set up the alternative hypothesis. So they're interested to test whether the mean number of enquiry per minute increase or not. Alright, so the keyword is increase. That means the lambda will be more than 1.55. So will increase means greater than, that means bigger than 1.55. Originally is 1.55, right? Yeah, so they want to test whether is it increased or not. So that means should be more than 1.55. Then, and they're interested to test on this statement. So lambda is greater than 1.55 also for 5-minute period. So we have completed our first step here. Okay, so first step done. Write out the null and also alternative hypothesis. Then we proceed to the second step. We need to calculate the p-value. Okay, so to calculate the p-value, right, we always need to use the observed value given in the question, which is a 5. And to calculate the p-value, we are interested to calculate the probability at the end of the data. So that means if let's say I have a value, observed value here, so I'm interested to calculate the probability on the left, or if your observed value is closer to the right hand side, then you have to calculate the probability on the right. Okay, so how should I decide the direction of my p-value? Should I put it as x greater equals to 5, or should I put it as x smaller equals to 5? So which one is the correct one for us to calculate the p-value? So there are actually two ways for you to decide it. The first one is more straightforward, where you can have a look for your alternative hypothesis. If your alternative hypothesis is a one-tailed test on the right greater than, therefore, the probability that we are interested to calculate is x greater equals to 5. So this is the most straightforward way. Okay, but this method cannot be applied if, let's say, we are having two-tailed tests. So you have to opt for second method. So the second method is you compare the mean of the distribution that you are using now. So we are having a Poisson distribution. So for Poisson distribution, right, the mean is equals to 1.55 because our lambda here for 5-minute period is 1.55, right? Then you try to observe where's my 5. So my 5 is towards to the right hand side compared with the mean. So if 5 is the observed value and it is on the right hand side, therefore to calculate the p-value, I should calculate the area which is more than or equals to 5. So this is the second way for us to decide it. Alright, okay, so for this question that we are doing now, it is more straightforward because our alternative hypothesis is having a greater sign. Therefore, very easily we can determine that it is greater or equals than 5. So why should I include the equal sign here? It is because of they are telling you that the total number inquired is a 5. So 5 should be included in your calculation for the p-value. Alright, so now after you decide the p-value is calculated by using this formula, okay, so please write out the formula for Poisson distribution. So I cannot find out the x greater equals to 5 in Poisson because it will be x equals to 5, then x equals to 6, and then x equals to infinity. Therefore, I have to take 1 minus the probability of x smaller than 5. So how to calculate the probability for x smaller than 5? It will be e negative lambda. For x equals to 0, first term, it is always a 1. For x equals to 1, second term, it is always the lambda. Then x equals to 2, it will be lambda square divided by 2 factorial. Then x equals to 3 is lambda cube divided by 3 factorial. And also x equals to 4 will be lambda power 4 divided by 4 factorial. So you can see that when we minus this one, it should be x smaller than 5. That means 5 shouldn't be included when I want to take 1 minus. Therefore, I will stop at x equals to 4. Okay, and after that, just use a calculator to help you and get the value for this. And you should get 0.0210. And we call this as p-value, which is a probability. Alright, so we also call this as p-value. So we have settled the second step here. Okay, so first step completed, second step completed, and now we are going to compare our p-value with alpha, which is the significance level. Okay, so let's try to imagine the graph. But of course, this graph is not the correct graph, alright? Okay, so let's say I'm having a bar, so the value of x start from 0 until infinity, right? Okay, and if I want to know how big is the area of rejection that I have for this test, it basically depends on the alpha. So alpha is 0.025. That means, maybe I should put a limit here first. Okay, so if my value of x falls inside this area, this whole area here is 0.025, which is the rejection area, rejection region. Alright, and the area for this part is 0.025. And now I want to compare it with my p-value that I calculated just now. So 0.021, the area that I get is 0.021. So is 0.021 bigger than 0.025 or smaller? So definitely it's smaller, right? So that means that when you want to draw the area, this is the area for 0.021, the blue color one. And that means this is the value 5. Okay, so you can see very obvious that this value 5 actually falls inside the rejection region because the green color one is rejection region. Okay, so you know that 5 falls under the rejection region. Okay, so first of all, you need to write out the statement of comparison first. So you should write something like this. When we are having the p-value, which is equals to 0.021, is smaller than alpha, which is equals to 0.025. Correct or not? Because the area is smaller than the rejection region. Therefore, when you try to imagine it in the graph, something like this, right? So you know that, oh, your 5 falls under the rejection region. So when your observed value falls under the rejection region, so you should actually reject the null hypothesis and try to make a conclusion in the context of this question. So you reject the null hypothesis means you accept alternative hypothesis, right? So there's enough evidence to show that the alternative hypothesis is true. So to show that the mean number of inquiry has increased. Mean number, okay, of inquiries has increased. Okay, yeah, so this is the end of the test and this is how we carried it out. So again, just to show you clearly, first step is this one, now an alternative hypothesis. Second step is calculate the p-value when you're having a lambda, when you're having a Poisson distribution or maybe discrete random variable. Then after that, the third one, you have to compare your p-value with the alpha, and the fourth one is decision and also the conclusion. So don't forget to write one sentence about the context, the conclusion about in the context of the question. All right. And one more thing to emphasize is when you're trying to compare the p-value and also the alpha, right? This diagram actually is not correct. Therefore, you shouldn't show it in the exam. But it is for us to visualize in a clearer way, right? Whether should I accept the null hypothesis or reject the null hypothesis. But in general, this is not the correct graph for Poisson. All right, so you shouldn't show this in the exam. Okay, all right, so basically this is how we carry out the test for the Poisson distribution to test about the number, right? Okay, so we come to question number 6. There's a continuous random variable x with the value 0 to 6 only has a probability distribution that is symmetrical. So I think this is a very important, the word symmetrical here. Okay, then there are two values, a and b, of x such that the probability of a until b is p, and then from b until 3 is 13 over 10p. So where the p is a positive constant. So they wanted to show that p is smaller or equals to 5 over 23. Okay, so for this kind of question, if let's say we can try to draw a simple diagram, right, to show the probability distribution function, then it will be easier for us to understand the question. Okay, but of course we don't know what's the proper shape of the distribution. So what we can do is that we just simply draw a simple graph. Okay, so let's say this is 0 and let's say this is a 6. Since the question tells us that the graph is symmetrical, right? Therefore, the line x equals to 3 will be the symmetrical line. That means the center line, the symmetrical line. Okay, so since they are symmetrical, right? So you can draw the graph in any way that you like. So if let's say, because it is just an assumption, right? So maybe your graph, if you want, you can draw it in this way. Okay, where it is symmetrical at x equals to 3. Okay, or if you want, you can draw it in a linear form, also can. Okay, as long as the line x equals to 3 is a, is a symmetrical line. That means in the center. Alright, so the graph are symmetrical at the line of x equals to 3. Alright, so no matter what kind of graph you want to draw, as long as they are symmetrical at this line, then it is okay. Because no matter how, this graph is not the correct graph. Alright, but we are just drawing it down to make sure that we can look at it in a clearer way, in the more, you can visualize it at least. Then you can do the calculation in the easier way. Okay, so let's say I draw a triangle like this. Right, so you should know that the total area of the triangle is equals to 1. Okay, the total area of the triangle should be equals to 1. That's the first thing. And the triangle is not the original graph. Okay, I just simply draw it. Okay, so you cannot tell me that, oh, can I use the base times height? Then that equals to 1? Cannot, because this is not the correct graph. It is just for us to visualize me, right? Okay, so now for this question, they are saying that when A smaller than B, the probability of x between A and B is equals to P. So I assume that maybe A should be somewhere here, and then B should be somewhere here. Okay, so this particular area between the A and B, right, is actually P. Probability of x between the B until 3 is 13 P over 10. So that means this particular area is 13 P over 10. Alright, so they want you to show that P is a positive, they want you to show that P is smaller or equals to 5 over 23. Okay, so how can we show that? Alright, okay, so first of all, from the diagram that I have here, right, I know that if I try to get the probability from 0 until 3, 0 is the minimum value, right? Then until 3 is the center line. So the area under the graph should be equals to 0.5. Agree or not? This is a general knowledge because the whole area under the graph should be equals to 1. And then if let's say I'm having from 0 until 3, right? The area should be half of it, so it should be equals to 0.5. Okay? And now I want to get what I see here. So you can see that I know the probability from A until 3, right? So I try to label it in red color here. So for this one, I know that the probability from A until 3 should be less than or equals to 0.5. Of course, it is impossible to be equals to lah. Alright, but maybe we don't know, we just assume that it is equals to 0.5. Who knows that maybe the A is a 0, right? Yeah, so we will write as x between A until 3 is smaller or equals to 0.5. So how to get the probability for x between A until 3? So from A until B is a P, and then from B until 3 is a 13 over 10P. So smaller equals to 0.5, which is a half. Try to add them together. You are having 23 over 10P. Smaller equals to half. And from here, you will know that P is actually smaller than 5 over 23. So this is how we prove it up. Alright, so I know that the steps here is a little bit long, but to explain it and let you understand better, so I think it is necessary for us to show you in the diagram. But this diagram is not the correct one. Again, I want to emphasize here, the diagram here is not the correct diagram, but it's just to help us to visualize the idea of the question. Right? Okay, so this is how we solve part A. And let's continue to next part. For part B, they want you to find the probability of B, x until from B until 6 minus A in terms of P. Okay, so let us go back here. So now they said B until 6 minus A. So first of all, we need to know where is 6 minus A first. So from 0 until A, this is the area, right? So 6 minus A should be also the same here. Okay, so that means that the distance here is the A. So this value will be 6 minus A. Can you understand what I say or not? Alright, so 6 minus A is here. And we are interested to find out the probability of B until 6 minus A. So I'm interested to find this one until this one. So now I label it by using the green color area. Okay, so from B until 6 minus A. Alright, okay, then now how can I calculate the probability here? If you have looked for the diagram here, right? So from B until 3, I already know this is the value 13P over 10. And now I want to know this white color area here, this part. How can I get the probability for this part? So if you are aware of the symmetrical characteristic for this distribution, okay, so this area and the red color area are actually the same. So this whole area here is actually equals to P plus 13P over 10. Because they are symmetrical, right? So this area is equals to what we have in front here. Alright. Therefore, if you have a look from B until 6 minus A, how to get the probability? So maybe I'm write my answer here for part B. Okay, so they're asking for B until 6 minus A. And to get the probability, you know that you have to add 13P, 13 over 10P, sorry. 13 10P, then plus this area, that means the total of these two areas in front, so it should be P plus 13 over 10P. Okay, so if you try to do some calculation and simplify it by right, you should get 3.6p for this question. Okay, so this is how we get the probability lah for this part. Alright, then let's proceed to part number C. Okay, so for part number C, now they give us a probability density function as shown like this. Okay, and then they are telling you that B is equals to 2 and then P is equals to 5 over 27. Alright, so how can you find out the value of A? Okay, so again, I need to maybe go back to our question here. Since they want us to calculate the probability for A, right? The calculate the value for A, right? So you can see that A is here now, right? Okay. Yeah, so maybe I try to erase all this first so that you won't see so messy. Okay, so now because we want to find the value A, therefore maybe to start and find out to help me to find the value A, what I want to do is like I want to focus on this highlighted area here. So for this highlighted area, if I write it out in a simple form, it should be the probability of X smaller than A, right? Yeah. So I must include the A in my solution so that later I can use it. I can continue to solve it and get the value for A. Alright, so I'm interested for this part. So some students might say that can I use maybe the probability between A and B? Also can. Since they already give you the value for B, right? Yeah, so for me, because I think 0 is still the easier number for us to apply, so I will just use 0. So 0 means from X from 0 until A, so that means X smaller than A. So how to get the probability for this part? So to get the probability for X smaller than A, right, the highlighted area here, it should be taking 0.5 minus the P minus 13 over 10P. Agree or not? So that means you are taking the half of the area under the graph minus the P minus the 13P over 10, then you are getting the yellow highlighted area here. Yeah, so I will start my step by using this particular equation here. Okay, so we go back to part C. Okay, so for part C, what I have just now is I'm having given that B equals to 2 and then P is 5 over 27, I'm using the equation where the probability of X smaller than 8, okay, is equals to 0.5 minus P minus 13 over 10P. So substitute the value of P inside. So 5 over 27. Okay, so by right, if you do the calculation here, right, the answer that you get should be 2 over 27. Okay, so for one continuous random variable, right, how can we actually calculate the probability? So we need to involve the integration, still remember? Right, so to involve the integration, so for probability of X smaller than A, that means I want to integrate from 0 until A for the function that we have, the probability density function that we have here. So it should be 1 over 36, then 6x minus x squared dx equals to 2 over 27. Okay, so 1 over 36 is a constant, so I take it out first. I integrate 6x. So integrate 6x, you're having 6x squared divided by 2. So eventually you're having 3x squared here. So all these are basic integration. Integrate x power 2, you're having x power 3 divided by 3. Then substitute in the value for A and also 0, which is equals to 2 over 27. Okay, then after that, how can we get the value of A? So again, slowly substitute your value of A inside the limit here, inside the value of x here. So you're having 3A squared minus 1 over 3A cubed, then minus the whole thing 0, equals to 2 over 27. Okay, Then now, what I want to do now is I want to simplify my equation here. Okay, so to simplify, right, what do I have now is I bring the 36 to the other side. So my right hand side left only 3a squared minus 1 over 3a cubed equals to 8 over 3. Then I don't like the 3, so I bring it over. I don't like the 3 as a denominator, right? So I bring it over so that my denominator disappear. Okay, so from here, I think it is quite obvious that you can see we are having a power 3 minus 9a squared then plus 8 equals to 0. Okay, so we are having a cubic equation in terms of a, and to solve for the cubic equation in terms of a, right, by right, okay, we should factorize it. Okay, but to factorize it, the step might be a bit long because you need to try and error what is the value, okay, that you need to use as a factor. Okay, so but of course this equation is not too hard for you to decide the root. Okay, you actually can try and error. If you don't want to try and error, then you can use the calculator to help you. Okay, all right. So for me, I'm using the try and error method lah. But the try and error method, right, when you are trying out to factorize the cubic equation for the a, basically you no need to show them in the solution. Of course, if you want to show, you can show. All right, the step is a bit long, so I might write it beside here. Okay, so by try and error method, right, we actually need to try and substitute the value of a, one value of a, so that when you substitute the value inside, the whole equation becomes a 0. So I think it's quite obvious that if you substitute a equals to 1, so you're having 1 power 3 minus 9, 1 square, then plus 8, it is equals to 0. So that means a minus 1 is a factor of this polynomial or cubic equation. So it actually involves a little bit like what we have in our pure maths chapter 1, right? The long division one. So if I want to know how to factorize fully, so I can use my long division method here. Okay, so plus 0a plus 8. So I'm having a minus 1. Okay, so the details of long division, I'm not going to discuss it here lah. So if you need some guidance, please have a look for the video that explain this part in the playlist, right? So negative 9a squared minus negative a, so you're having negative 8a squared. Okay, then after that, I want to have the value plus 0a plus 8. So another long value here is negative 8a. So negative 8a squared, then plus 8a. After that, minus 0 minus 8 become negative 8, then plus 8. So I must have negative 8 here. So negative 8a plus 8. So you can see that it is divisible completely by the factor a minus 1. So this part, basically, it involves the knowledge in long division for chapter 1 in our pure maths, paper 3. Okay, but of course, if you are lazy to do that, you can use calculator to help you straight away. But of course, for calculator part, they won't give you this quadratic factor as well. So I think you still need to carry out the long division. Okay, all right, then after that, since I know that these two are the factor, right? So I can write out my factorization form, a minus 1, then a squared minus 8a minus 8 should be equals to 0. So from here, I have to solve two equations here. I'm having a minus 1 equals to 0. Another one is a squared minus 8a minus 8 equals to 0. So very easily, you can get one of the answer, which is a equals to 1. Then for this part, you're having the quadratic equation in terms of a. So to solve for it, you can use quadratic formula, or if you want, you can use the calculator to help you. Right, so I'm having negative b plus minus b squared minus 4ac. So remember the quadratic formula. So b squared minus 4ac divided by 2a. Okay, so when I simplify from this part, I'm having two values here. One value is a equals to 8.90. Another one is a equals to negative 0.890. Okay, so when we are looking at these three answers obtained for the a, right? Okay, so we go back to our question again. I just need to recall back again. Okay, so our question did tell us that x is between 0 until 6. That means all your value of a should be also between 0 until 6. It cannot be outside the 0 and also outside the 6. Because a is between. Okay, it's the some value inside, right? If you have a look for the diagram here. So a is actually between 0 until 6. Alright? Okay, so let us observe again for the answer that we have. So basically, you have to reject both. So both rejected. Okay, so both rejected because out of the x defined. Okay, so that means what? That means our final answer has only one value for a, which is a equals to 1. Okay, so this is how basically we solve question number 6. Alright, then maybe some of you might want to ask, why do I need to show, okay, how to factorize the a? Can I directly press the calculator and get all the answer for the a here? Okay, so for your information, if you refer to the marking scheme, right, actually marking scheme did ask us to factorize the equation and solve them. Alright, although we haven't learned the technique, right, in a proper technique, right? Alright, but of course we learn about the long division here, but the try and error part, actually you need to try a little bit on your luck to decide a correct value for the a. Okay, so you have to think, after you substitute this value out, what's the value that you can make the whole equation become 0? Okay, and usually we will try it by using some very basic number first. Alright, okay, so to fulfill what they show in marking scheme, right, to get the full marks, so we have to factorize it. But of course, if let's say like last time, if let's say we didn't learn how to factorize it, we can press calculator directly. Okay, right. But for this marking scheme, for this year, this specific set of marking scheme, they actually did show, or they did want us to show the factorization. Alright, so it is given mark, I think, if I'm not mistaken. Alright, so this is the reason why I have to go through with so long the method to get the factorization here. Alright, okay, so this is how we solve the question. Alright, so now we are at question number 7, which is the last question for this paper. We are having the biologists want to test whether the mean concentration mu in suitable units of a certain pollutant in the river below the permitted level of 0.5. Okay, so I think you need to highlight the keyword below. So again, why we need to highlight this keyword here? So below is actually one of the keywords to help us set up the alternative hypothesis later. Because they want to test whether is it below the permitted level. So what's the original permitted level? It is 0.5. Okay, so that means on this 0.5, right, it is actually the mu, the population mean, that they assume that it is this value all the while. So she measured the concentration of the pollutants at 50 randomly chosen locations in the river. So these are the results that we have. Okay, so all these results, right? Okay, so all these results are the sample result, the result from sample. Okay, and now what they want us to do is they want us to carry out the test at 5% significance level of the null hypothesis this one against the alternative hypothesis this one. Alright, so now we only have the population mean, which is 0.5, and they want us to carry out a test. When we want to carry out the test, right, we have to make sure that we know the population variance. Okay, we have to know the population variance. But the problem now is we only have the value in sample, so we won't have the population variance. For the very first step, what we need to do is we need to try and calculate the unbiased estimated population variance first, so that we can use it in the hypothesis test later. Alright, so we need to calculate unbiased estimated variance. for population. All right. Okay, so again, what is the formula? So just in case if you already forget the formula for this unbiased estimated variance, you can actually get it from our formula booklet. So let me have a look. Yeah, where's the formula? This one. There are two here. First one is this one, second one is this one. So according to the data that we have, right, it is easier for us to use the second one because we don't have the value for x minus mean square summation. So we only have this. So we are going to use this formula, right? Okay, so try to remember it. If you cannot, then of course you can refer to the formula booklet. Alright, so I will write out here. So we are going to use the formula where it is equals to 1 over n minus 1, then the summation of x squared minus the summation of x squared divided by n. Okay, so put in the value now. So I'm having 1 over 49. Summation of x squared is 13.02. Okay, so minus 23 squared divided by 50. Okay, when I try to calculate this value, right, if you can get a very nice fraction, please keep it in the original fraction. So it should be 61 over 1225. So I keep it as original fraction because of this is not my final answer. So I have to use this value later in other calculation. So to make sure that my calculation is accurate, therefore you have to keep it as original fraction first, right? So this is the estimated variance, population variance that we have. And after that, we also need to know what is the value for the sample mean to calculate the test statistic later. So what is the sample mean here? So sample mean is very straightforward. You take 23 divided by 50. So 23 divided by 50, and you are having a nice value, which is 0.46. Okay? Alright, then after that, after you get all the things that you need in the carry out the test, then we can start the hypothesis test now. So again, just to recall back very quickly, what are the steps that we need to include here? So first step, you have to calculate the null and also the alternative hypothesis. Okay, then after that, if you want, you can try to get the critical value. Critical value, you get it from the normal distribution table. The third one is you try to calculate the test statistic. Okay, then after that you compare them. Compare what? Compare the critical value and also the test statistic. And after that, for the last step, you do decision. You make decision and also write out the conclusion. So you can see that this is slightly different from what we discussed just now because just now one is actually the discrete random variable. But for this one, we are having a normal distribution. Okay, so maybe you will ask again, hey, I didn't see the keyword normally distributed, so how can I assume that it is normally distributed? Okay, so the reason is because of this one. When your sample size is large, more than 30, so the sample mean will be actually approximately normally distributed. Okay, so for normal distribution, when you want to carry out the test, for this one, I'm using the critical value approach. I didn't use the p-value. P-value means just now I calculate the probability one. So now I'm using the critical value approach. So this is what I'm having. I need to follow, right? Okay, so let's start. First step, set up the null and also the alternative hypothesis. I think it is already been given, right, just now in the question. So mu is 0.5. And after that, mu is less than 0.5. So this is the first step. Okay, so for the second step, you should have preferred to do the find out the critical value first. So to find the critical value, right, it depends on your significance level. So this is a normal distribution graph, right? So I just draw a normal distribution curve first. Assume that it is symmetry. Okay, so what is the percentage of my significance level? 5%. If I have a look for my alternative hypothesis, it is a one-tailed test on the left, right? So it actually means that my rejection region is on the left. So this particular area is 0.05, 5%, so 0.05. That's the critical value. So the critical value is the exact value at this part. So this is critical value. I need to know exactly what's the critical value for this part, okay, for this 0.05 area lah. If you want to find out the probability of 0.05 from the normal distribution table, you're not able to get it. Okay, because if you have a look, okay, so I think I have to erase all this here. Okay, so if you have a look for all the probability that we have here, so what is the probability in the normal distribution table? So probability basically is all the value inside here. All these are the probability. Okay, so you can see that all the probability here, there's no 0.05. Therefore, to find out the value of Z, yeah, you actually have to use the larger value that is complement to each other one. So this large area should be 0.95 lah. So that 0.95 plus 0.05 equals to 1. So instead of using 0.05 to find the value of Z, I have to use the 0.95. So you can find out 0.95 from this part, or to save our time, you actually can use a shortcut table here. So can you see that the probability equals to 0.95 and the value of Z is 1.645. Come back to our solution. So this critical value is 1.645. But again, if you have a look for the diagram here, right, you know that the Z is on the left hand side. The center is a 0. So since your Z is here, right, so the critical value is actually negative 1.645. Okay, so this is my second step here. So the critical value basically depends on the significance level that you have. And also whether is it your test is 1 day or 2 day test, right? Okay, then after that I have to continue to calculate the test statistic. So what's the formula for test statistic in when you want to test about the population mean? Okay, so to calculate the test statistic, you have to take the sample mean minus the population mean divided by standard deviation of the population over square root n. So this is the formula. So let us slowly put in all the value here. What is the sample mean that we calculate just now? 0.46. Is the population mean that we want to test? It is 0.5. Okay, then divided by what? Divided by the population standard deviation. Where's the population standard deviation? So just now we already estimate the variance of population, which is this one. So standard deviation means you have to take square root of this, alright? So 61 over 1225. Okay, so square root (61 over 1225) divided by square root n, so divided by sample size n, which is divided by 50. Okay, so if I try to calculate the Z value here, I should get 1.2675, or you can write as 3 significant figure, which is negative 1.27. So this is our third step to calculate the test statistic. Okay, then now you want to compare the test statistic and also the critical value so that it can help me to do the decision, right? To make a decision. Okay, so our test statistic is negative 1.27. We come back to this diagram. Where is negative 1.27? So negative 1.27 is before the negative 1.645. So that means this particular value should be negative 1.27. Because negative value, this negative 1.27 should be closer to 0 compared with negative 1.645, right? So therefore this is negative 1.27. Then now, if you have a look for this negative 1.27, this blue color line, right? Where did it fall? It actually falls inside the acceptance region, because we know that this is our rejection region on the left hand side. So the white color one will be our acceptance region. So from here, this is how we made the decision. Okay, then of course we need to write out the comparison first. So you can write since. Okay, so since the test statistic negative 1.27 is greater than the critical value which is negative 1.645. But of course, for me, right, when we write out this one, it's very hard for me to decide. Actually, for me, I always imagine the diagram in my mind. So I know that, oh, negative 1.27 falls under the acceptance region. Therefore, your conclusion or decision will be you do not reject the null hypothesis. So do not reject the null hypothesis. That means there's no enough evidence to show that the pollutants is below the level, right? So you can write a conclusion in the context of the question. There's insufficient evidence to show that the pollutants in in a river, in the river is below the permitted level. Alright, so this is how we carry out the test for this particular question. Okay, then let's continue to the next part. Okay, now they tell you later, a similar test is carried out at 5% significance level using another sample size 50 and also the same hypothesis as before. You should assume that the standard deviation is unchanged. So again, I want to write out my unbiased estimated population variance. It is equals to 61 over 1225. Okay, now they said given that in fact the value of mu is 0.4, then you have to calculate the type 2 error. Alright, so how should we calculate the type 2 error? The definition for type 2 error is this one. You accept the null hypothesis when the null hypothesis is false. Okay, so to calculate the probability for this part, right? Accept the null hypothesis, I actually need the acceptance region. Okay, so I need the acceptance region. So in this question, they didn't give me the acceptance region. They also didn't give us the rejection region. So let's recall back. Just now in part A, right? So I did draw the graph like this when we want to carry out the test. And I think I did mention that this area is actually the rejection area. And the critical value is negative 1.645. So this is the diagram I showed you just now in part A, right? So that means if I want to find out the rejection area, you can use this result. So what's the rejection area here? So rejection area means that your Z must be smaller than negative 1.645. Okay, if your Z is less than negative 1.645, then basically you reject. But you might ask, hey, I want to find out the acceptance region. So you can find out the rejection region first, then the opposite side of the rejection area will be actually the acceptance area. Okay, all right, so we'll start from this part. Okay, according to the graph that we draw, we know that this is the rejection region. So Z smaller than negative 1.645. What's the formula for the Z here? So it should be X minus the mean divided by the population standard deviation over square root n and less than negative 1.645. So what's the sample mean? I don't know and I want to find it out. What is the population mean just now? 0.5. What is the standard deviation of the population? So again, it remained unchanged. So it should be still 16 over 1225 divided by the sample size, which is 50. And it is smaller than negative 1.645. Okay, so please try to move all the number to the other side and try to get one inequality of the sample mean. So if you didn't do any careless mistake, your sample mean should be this value, like 0.448, 0.868, 0.32. It is a long value. Of course, if you want to cut it short, become 3 significant figure, you can try. But for me, because I want to get the most accurate answer later, right? So usually I will keep the number as long as possible. Okay, so after I get this one, this is the rejection area. So if this is rejection area, that means acceptance area is what? So the acceptance region will be the opposite sign for this one. So it should be x greater equals to, okay, or maybe greater than 0.44808680032. Okay, so once I get the acceptance region, I can start calculating the type 2 error now. So what's the definition for type 2 error? You accept the null hypothesis when the null hypothesis is false. Okay, so we write out what we want. So accept null hypothesis means that you fill in the acceptance region. So you accept null hypothesis when x sample mean is greater than 0.44808680032. When the null hypothesis is false, so they will give you, because they said null hypothesis is false, means that our population mean is not equal to 0.5 anymore. It should be a value less than 0.5. But what's the value? The question will give you actually. So the mu is now 0.4. Can you see that? Alright, so I'm having the mu equals to 0.4. So how can I calculate the probability for the sample mean here? Okay, so this is again a normal distribution, right? Because the sample size is large. Therefore, to calculate the probability, I have to change it become z. How to change it become z? You have to rationalize it, standardize it. So to standardize a variable from x to z, you have to minus the mean. And the mean now that you use cannot use 0.5 anymore. You have to use the value that they give you, 0.4, divided by population standard deviation over n, over square root n. So divided by square root of population variance that I calculated just now, and I put a square root here, then divided by the sample size, which is 50. Okay, then next, try to get the value of z up to 3 decimal places. So it should be 1.524. And to calculate the probability, you have to take 1 minus. So look for 1.524 from our table. So 1.5 is here. 2 is this one. Okay, so 4. So what's the 4? 4 is here. So you go to the back. This is the value that you need to add. So you take 9357 plus 5. So from here, you should have 9362. Okay, so this is the smaller than 1.524. So if I want to get the area greater than 1.524, I have to take 1 minus 0.9362. So by right, the correct answer should be 0.0638. Alright, yeah, so this is how we basically solve the questions for this paper. Alright, so thank you very much for watching this video.